December 7, 1941, Pearl Harbor, Oahu. The sun hadn't risen yet, but the base was already awake. Engines idled. Fuel trucks rumbled between moorings. A few sailors drank black coffee on deck, staring at the water that shimmered like glass. Inside the harbor workshops, welders tested torches against sheet steel. Sparks fell in bright arcs, unnoticed, unremarkable. None of them knew that within the hour the sky above them would turn to fire. At 7:55 a.m., the first wave appeared. 183 aircraft slicing through the morning haze. Bombers, torpedo planes, fighters. They came in low over the mountains, sunlight flashing on wings marked with red circles. Sirens. Then thunder. Then silence, broken by the scream of bombs. In less than 5 minutes, the Pacific Fleet, once thought untouchable, was drowning in its own harbor. Arizona, Oklahoma, California, West Virginia. One after another, the names echoed through the radio chaos. But beneath that chaos, another kind of battle had already begun. Deep inside the Naval Engineering Annex, Building 101, 3 officers stood over a drafting table buried in blueprints. The air shook with distant detonations. Glass trembled in the windows. They didn't flinch. "Activate Plan C," one said. Plan C wasn't a counterattack. It wasn't even a defense order. It was something stranger. A contingency the Japanese planners had never discovered. A mission built on pipes, pumps, and steel. While the fleet above them burned, a hidden network of engineers, electricians, and divers began moving. They started generators, opened valves, flooded ballast tanks. Their task wasn't glory, it was survival. By 8:10, fuel lines under the harbor floor rerouted pressure away from the docks. By 8:30, mobile pumps were already pushing seawater out of damaged compartments on the West Virginia. By 9-mile, repair pontoons were being towed into, positioned by tugboats that hadn't even finished dodging, bombs the attack that was meant to cripple. America's Navy had triggered the activation of the most ambitious naval engineering project ever attempted under fire. Most historians call December 7th a day of infamy, but for the engineers who worked in smoke and oil that morning, it was also a day of testing. Every system, every line, every backup they'd designed for months would either hold, or the Pacific Fleet would die here. As the Arizona exploded and the harbor turned black with fuel, one junior officer wrote in his log, "We are no longer defending the base. We are defending the infrastructure of the war." That line would never make the newspapers. It wasn't meant to, because what happened below deck, beneath the flames, changed everything. It would turn a disaster into a recovery, a defeat into a strategy, and by the time Japan realized it, the outcome of the Pacific War had already begun to shift. To understand how, we have to go back, months before that morning, to a secret construction order issued quietly by the U.S. Navy Bureau of Yards and Docks. An order so classified that even most fleet captains never saw it. Its goal, make Pearl Harbor impossible to destroy. 8 months before the attack, the island was changing. Pearl Harbor had always been a harbor of peace, a place of Sunday inspections, brass polish, and steady routines. But in early 1941, the sound of hammers began to echo through the shipyards long after sunset. The Bureau of Yards and Docks had issued a new series of orders. No speeches, no headlines, just sealed envelopes marked Confidential Continuity Construction Program. What it meant was simple and terrifying. Washington didn't know when a war would start, but it knew one was coming. Across the base, cranes rose like skeletons against the orange sky. Crews dug trenches for new underground fuel lines, triple-walled, insulated, buried in reinforced concrete. If above-ground tanks burned, the fleet would still have fuel. Welders cursed through their masks. Divers installed underwater net anchors along the channel floor. Shore electricians rerouted cables into subterranean conduits that could survive a near miss. Every blueprint carried the same signature, for continuity under attack. At the time, no one outside the engineering corps paid attention. Pilots talked about tactics. Admirals talked about deterrence. The engineers talked about time. How much time could the fleet buy itself if, or when, the worst happened? They designed for hours, not years. Every new pipeline, every redundant switchboard, every mobile repair pontoon was calculated to extend life by minutes. Because in combat, minutes decide wars. By the summer of 1941, Pearl Harbor looked finished, but it wasn't. Under the docks, sealed concrete vaults held spare turbines, generator cores and fuel pumps, each labeled by weight, not by name. Portable cranes and barges were fitted with reinforced mooring points. Floating dry dock sections were quietly shipped in pieces and assembled in remote coves off Oahu's coast. No one called it a defense plan. It was a resurrection plan. When Lieutenant Commander Harold Douglas, an engineer from the Pacific Fleet's Maintenance Division, reviewed the blueprints, he wrote a single line in the margin. If they hit us here, we rebuild before they reload. That was the mindset, not avoidance, recovery. And yet not even the men who built those systems understood what they were creating. They thought they were preparing for sabotage or maybe a small air raid. No one imagined hundreds of aircraft striking at once. Still, when the Bureau ordered additional portable pumps and welding units from San Diego in November 1941, the timing was uncanny. The shipment arrived in Hawaii 5 days before the attack. 4 repair pontoons, 6 diesel generators, 12 high-pressure pumps, all stored under tarps near Pier 4. When the Japanese pilots came screaming out of the dawn, those pumps would become the heartbeat of the harbor's survival. At that moment, they were just boxes waiting in the tropical heat. History would open them soon enough. When the first explosions hit, the engineers didn't run for cover. They ran for their maps. The noise was impossible to describe, a physical pressure that cracked windows and bent air. The entire harbor shook. Men on the docks thought the oil tanks had blown. Then they saw the sky filled with planes. Within minutes, the chain of command fractured. Signals failed. Phone lines died. Anti-aircraft crews fired blindly. In the confusion, no one realized that the biggest threat wasn't above them. It was below. Pearl Harbor was never designed to hold wrecks. The docks were built to maintain ships, not to rescue them. If a battleship sank at its mooring, it could block the entire harbor. Fuel lines, cranes, and power conduits ran beneath those moorings. A single ruptured pipe could turn the bay into a lake of burning oil. At 8:06 a.m., a bomb hit the repair yard's power substation. The lights flickered once, then went dark. For 30 seconds, the heart of the base stopped. And then, somewhere under the administrative building, a generator coughed to life. Plan C was activating. The engineers had anticipated a blackout. 6 months earlier, they'd buried redundant conduits beneath the dry dock floor, shielded in concrete, sealed against fire and water. Each conduit could reroute power from the auxiliary diesel plant directly to the piers. It wasn't glamorous. It was survival math. Still, power was only part of the equation. The real nightmare was flooding. When a torpedo punched through the hull of the West Virginia, seawater rushed in at thousands of gallons per minute. Every cubic foot that entered made the ship heavier, dragged her deeper, pulled at the mooring lines until they snapped like wire. If she rolled, she would crush the Tennessee beside her. The repair crews had trained for this in simulations, never expecting it to happen. Now it was real. They sprinted to the storage sheds, hauling out portable pumps the size of small cars. Each pump could push 3,000 gallons a minute, if they could get them started under fire. Oil slicks burned on the surface. The air was a haze of smoke and heat. 2 engineers were killed moving hoses across the pier. Others worked through the flames, coughing, blinded, guided only by touch. At 8:12, a second torpedo struck the California. The impact tore open the port side, flooding the forward magazines. If the water reached the ammunition lockers, the entire ship could detonate. One chief engineer, Lieutenant Robert Kessler, made the call. Seal the bulkhead. Flood the opposite side. Keep her level. It was a gamble. Controlled flooding to counter uncontrolled flooding. Within minutes, pumps were running, balancing water pressure to keep the ship upright. From the air, the Japanese pilots saw columns of smoke and assumed they'd sunk everything. From below, the engineers saw a different picture. Steel deforming, compartments flooding, but systems holding, one by one. Every ship in the harbor was a living equation. Buoyancy, displacement, intake, output. Every second that passed was another calculation in survival. By 08:30, communications officers were gone, dead or wounded. The only coherent voice left was engineering. They coordinated fuel cutoff, pressure control, ballast correction, and emergency patch teams through hand signals and shouts. What the attackers didn't know, and what they couldn't know, was that every pipeline, every conduit, Every emergency valve the engineers had installed in secret months earlier was now buying the United States Navy something priceless. Time. Minutes turned into hours. Hours turned into a chance. By 09 a.m., the harbor was smoke and noise. Ships burned, men drowned. But the engineers were not done. Under the shattered pier, pumps thumped like mechanical hearts. Pressure gauges trembled, needles quivering at the red line. Every clang of steel was a heartbeat, not of war but of repair. Across the base, a convoy of tugboats began towing a strange cargo toward Battleship Row. 4 floating pontoons lashed together, each carrying welding rigs, acetylene tanks, and cranes scavenged from the shipyard. They were part of the secret repair island project, hidden in a lagoon outside the harbor until that morning. The plan had been drawn up in September 1941 by Commander William Paxton, an engineer no one outside yards and docks remembered. His idea was radical. If a ship couldn't reach a dry dock, bring the dry dock to the ship. Now his theory was being tested. In Fire and Oil, the first pontoon reached the West Virginia at 09:25. Divers went over the side with welding torches wrapped in rubberized casings. Underwater, the heat was muffled, the light dim. They couldn't see, only feel. The steel was hot, alive, flexing under pressure. On the surface, crews fed down sheets of prefabricated plate, cofferdams designed weeks earlier for an exercise that never happened. Bolted in sections, sealed with compressed air, the plates turned a flooding gash into a temporary wall. Inside, pumps went to work. Water poured out in brown torrents. By mid-morning, they'd stabilized the ship enough to keep her from rolling. What the Japanese believed was a total loss was, in reality, a controlled wound. At the same time, fuel engineers were fighting a different war. The main surface tanks had been strafed and set alight, but deep underground, the backup system came online automatically. Triple insulated pipelines rerouted fuel through concrete vaults under Dry Dock 2, feeding still operational destroyers and submarines. Without it, no ship could have escaped the harbor. With it, the fleet still had pulse. Inside Building 101, the operations room glowed red from emergency lamps. Maps, phone receivers, and mechanical calculators covered every inch of the tables. An ensign was calling out coordinates of damaged ships. Another was scribbling rates of dewatering in chalk. Section 2, 14,000 gallons per minute. Section 4, holding steady. The voice was calm, focused. Outside, the air stank of burning oil. Inside, the war had become mathematics. At 10 Karn, one of the engineers looked up from his clipboard and said quietly, "She's not sinking anymore." No one cheered. They didn't have time. The next task was bolder. The Nevada, the only battleship that managed to move during the attack, was now grounded near Hospital Point, listing and afire. If she slipped back into deep water, she would block the entire channel. The engineer's solution was as reckless as it was brilliant. They'd beach her on purpose. Tugs strained at her hull. Pumps roared. As the tide turned, they drove her aground in the shallows. A crippled giant turned into a barricade. Later, sailors would say she looked defiant, gun barrels still raised toward the smoke. But the truth was simpler. She was a wall, holding the harbor open for everyone else. By noon, more than half the engineers had been awake for 36 hours. No one left. No one asked to. What had begun as an invisible network of pipes, pumps, and generators had become the backbone of survival. Pearl Harbor wasn't saved by chance. It was saved by design. By sunset, the smoke had settled into the hills. The harbor was quiet again, too quiet. Oil fires still burned on the surface, slow and black, turning the water to glass. Bodies drifted beside shattered lifeboats. The air smelled of diesel, blood, and salt. From the air, Pearl Harbor looked finished. From the ground, it was beginning to move again. In the shipyard, cranes were already lifting twisted beams from the water. Pontoons hummed under floodlights powered by the backup grid. Divers surfaced with pieces of torn hull, handing them up like relics. Each fragment was catalogued, tagged, and sent to the engineering annex for analysis. They weren't salvaging. They were learning. By midnight, the first temporary patches on the West Virginia held. The California stopped taking water. The Nevada lay grounded but intact. The destroyer helm was fully operational and had already begun escorting hospital ships out of the harbor. The Japanese pilots who returned to their carriers that afternoon believed they had crippled the U.S. Pacific Fleet. They hadn't. They had destroyed battleships, but not the fleet's ability to fight what they couldn't. See, beneath the smoke was that Pearl Harbor's heart had kept beating. The fuel system worked. The repair system worked. The communications grid, rerouted through underground conduits, came back online within 12 hours. And something even more important had survived: the infrastructure that allowed America to recover faster than any nation in history. On the morning of December 8th, while the newspapers printed the word infamy, a line of trucks rolled into the base carrying welding rods, fresh pumps, and oxygen tanks. The same engineers who had worked through the attack were now drafting repair schedules by flashlight. No ceremony, no speeches, just work. By December 10th, 6 ships were being refloated. By December 20th, dock power was fully restored. By January, oil was flowing at pre-attack levels. What the Japanese thought was a permanent wound had already begun to heal, faster than their intelligence believed possible. Inside Japan's Naval General Staff, the first reports of this reached Tokyo by the end of December. At first they were dismissed as American propaganda. Then photographs arrived, taken by submarines shadowing the harbor, smoke gone. Cranes moving, ships upright again. Admiral Yamamoto stared at the images in silence. He had predicted the danger before the war. In the first 6 months I will run wild. After that I cannot promise victory. It had taken exactly 1 month. The irony was unbearable. The attack that was supposed to crush American naval power had instead hardened it. The engineers of Pearl Harbor had turned defeat into a blueprint for resurrection. Every pump that started that day was a defiance of expectation. Every repaired hull was a declaration that the war would not end here. Pearl Harbor had been designed to survive, and now that design was rewriting the balance of the Pacific. In the months that followed, Pearl Harbor changed shape. The scars became blueprints. The wrecks became classrooms. At Dry Dock 1, engineers studied the bent hull of the West Virginia the way a surgeon studies an X-ray. Every fracture, every burn mark, every plate that held under pressure became data. They mapped the damage in millimeters, photographed it, and built a manual titled Rapid Damage Control Procedures, Pacific Fleet. Copies went to every U.S. naval base from San Diego to Manila. By the spring of 1942, those same design principles were traveling with the fleet itself. Floating dry docks now moved across the Pacific like portable islands. Repair barges followed invasion forces, setting up within days on coral beaches. Fuel lines were buried deeper. Power conduits duplicated. The continuity under attack doctrine, born in secret before the war, had become official Navy policy. Even the Japanese, in their later assessments, noted the transformation. Captured reports from 1944 described enemy bases capable of repair beyond expectation. They meant it as an observation. It read like an admission. By war's end, the United States had commissioned more than a dozen mobile dry docks, 300 repair ships, and over 20,000 trained naval engineers. Every one of them traced their lineage to that morning in December, and the legacy did not stop with victory. In 1946, when the Navy declassified portions of the Pearl Harbor repair logs, one memo caught historians' attention. It read, "Future war may again begin with surprise. Ensure that no first blow removes the ability to respond." That sentence became the cornerstone of modern resilience planning. It echoed through shipyards, air bases, and later, through entire nations. Pearl Harbor's engineers hadn't just rebuilt ships. They had re-engineered the concept of survival itself. 80 years later, the lesson still stands. Resilience is not reaction. It's design. Modern fleets in Guam, Diego Garcia, and Yokosuka still carry the DNA of Pearl Harbor's hidden network. Redundant power, modular docks, mobile repair pods. Every cable buried beneath the concrete, every generator doubled, is a whisper from 1941. Build for the day the lights go out. You can see the same philosophy far beyond the sea. Data centers with mirrored servers, hospitals with twin oxygen systems, cities with underground power grids designed to reroute within seconds of failure. They are all descendants of that same quiet engineering faith, that systems should never depend on luck. Technology has changed. Principles have not. Every time a modern Navy talks about continuity of operations, they are quoting the engineers of Pearl Harbor without knowing it. When disaster strikes, whether by bomb, storm, or cyber attack, the survivors are never the strongest. They are the best prepared to rebuild while the smoke is still rising. That was the real secret mission of December 7th, 1941. Not revenge, not even defense, but proof that foresight, buried in concrete and steel, can outlast fire and chaos. Pearl Harbor was a wound that healed itself, and the scar it left became the blueprint for every system that refuses to die.